Okay, so your test tomorrow is going to be approximately 20 multiple choice questions, maybe a little bit under, maybe a little bit over. It's all going to be multiple choice on a Scantron. Okay, so what is it over? It's over physical and chemical properties and changes. It's over saturation, the video we did with the video notes, and the lab we did with all the sugar labs. And then the measurements, which was the last set of notes we did, accuracy, precision, quantitative, qualitative, and then scientific notation. Okay, so on your Google Classroom, class code H as in hotel, K as in kilo, G as in golf, 76, F as in foxtrot, J as in Juliet. Okay, we're going back to chemical and physical properties, saturation video with the notes, and then accuracy, precision, scientific notation. So it's all right here. Okay, first thing I'm gonna do is I'm gonna go over since I'm doing them in kind of an order, chemical and physical properties and changes. Okay, so you can watch it. I'm just gonna pull up the PowerPoint right now. And it's going to help us with our review sheet. All of the things from the test are going to be examples from these right here. Okay. So, real quickly. Okay, physical properties. Properties that can be measured or observed without changing the identity or the composition of a substance. So, when you're trying to figure out, is it a physical or a chemical, if after you do your measuring, it's still the same thing, it's a physical property. You've just kind of manipulated it a little bit and it's still the same thing. If you experiment with it and it's no longer the same substance, it was a chemical property that you figured out. So, for example, it says the chemical makeup is not changed. For example, if you figure out the color, you didn't change it. The odor, texture, taste, even if you freeze or melt something, you did not change its composition, kind of like ice melts or water freezes, okay? You can figure out its density, mass, hardness. All of these are just physical properties, okay? Chemical properties, you are changing something. Indicates how a substance reacts with something else. These properties are only observed when the substance undergoes a change. If you test to see if it's flammable, has a flame, combustible, burnable, reacts with, you can never go back to the original substance, okay? Now, physical changes. Okay, same, very similar to physical properties to where the original substance did not change. So oh my gosh, I keep on thinking there's one more. Okay, so changes appearance without changing composition. For example, cutting, breaking, pulverizing. You cut grass. It was one long blade of grass. Now it's two short blades of grass. It's still grass. Same grass as before. Breaking. It was a full glass or a tall glass. Then you break it. It's little bitty pieces in a million pieces, but it's still glass. Okay, still the same thing. You did not create anything new. For example, melting, freezing, boiling, subliming. Okay. Chemical changes. Ready? Forms a new substance with different properties. You cannot go backwards. So for example, rusting. If a metal rusts, can you ever get that original metal back? No. Rust is new. Can't go back to metal. Burning, if you burn a piece of paper, that ash and gas release will never create that paper again. Corrosion, digestion because of the enzymes, respiration and decaying. Okay. So that is a good summary of physical chemical changes. Now let's do saturation. So I'm going to go back to Google Classroom and go to this video, and this video is where we came up with the labs for.
In this video, we're going to look at 3 types of solutions. Unsaturated.
For the rock candy saturation, the supersaturation lab, okay? If you need to rewatch this video, I'm going to use the tables from this video in the quiz or in the test. So it tells you what unsaturated is, saturated, and supersaturated, okay? So you have to know these. Ready? The solute. Remember when you solute, you put it in there. The solute is the substance going in. So there will be a question where you have to figure out in this problem, which is the solute, where's the solvent? Water is the universal solvent, so the liquid is the solvent. Liquid is the solvent, the solid you put in. So you have to know solvent, solute. You should have got your 10 video notes back. That was in there. You do have to know unsaturated, saturated, and supersaturated. Okay, an unsaturated solution is a solution where, let's say what? Yes, you haven't reached the maximum capacity where it holds the solute. So guys, what an unsaturated solution is when you have solute in there, but it can still be more compact, okay? So if the
saturated, and it's easier, we're just going to use a made-up generic salt.
I want to get that table. Okay, so here's the solubility chart for, it was salt. They said to get it saturated at 20 degrees Celsius, and we'll pretend like all this is at 20 degrees, you need 15 grams of salt. So that means that until you hit 15 grams, 1, 2, 3, 4, 14, 14.99, until you hit 15, you are unsaturated. You can still hold more, Once you hold 15, you are now saturated. Saturated is where you're holding the max amount of solute. Supersaturated is where you're what? Holding more solute than theoretically possible. And the only way to do it, does anybody remember?
Bring it to a higher temperature.
Good. You bring it to a high temperature, you get it to be saturated at a higher temperature, and you cool it. And then whatever you're doing, salt, sugar, stays in solution. Now, we did a lab based on that. And so, do you remember when we made the sugar, okay? Water, the sugar water, okay? It was kind of syrupy, but we did not see the crystals. Only when we put the seed starter in there, which was your string or your stick with some sugar on it, only when we put that in there and let it kind of go for 3 to 5 days, then all of a sudden the sugar, not salt like this video, started expanding outward from those seeds. Also, you see sugar crystals across the top, across the sides. So what was happening was as the solution was cooling, the sugar was falling out of solution, but it was falling out on the candy stick and around the sides. So technically, if we would go back and we would hold up our rock candy beaker, all of the sugar fell out of solution and was back at room temperature, but it was just in the form of rock candy instead of little individual crystals. Okay, so if you need help with saturated, unsaturated, supersaturated, solute, solvent, okay, watch this video. It's on Google Classroom. Okay. Last but not least, and this one has a lot of the questions. This is this was 3 videos. Remember we did this last week? These are just extra videos to help you with some of these topics. So for example, qualitative versus quantitative. So these are all ways we take measurements. Qualitative looks at the quality of the whatever you're looking at, okay? Quantitative looks at the numbers associated with it. Which one is better, especially in science? Quantitative. I would say in elementary school, you do a lot of qualitative, and then as you go up, you could do quantitative. So for example, if we were looking at qualitative questions, we would be looking at open-ended questions like, just to get the opinion. What do you guys enjoy eating for breakfast? Instead of something quantitative that was like, how many of you eat breakfast? Okay, so when it's open-ended, it's qualitative. When it's a number, it's quantitative. Okay, if there was a tree outside, qualitative analysis about the tree would be like, is it healthy or not healthy? And you would use your opinion. What color green is it? Quantitative would be like, how tall is it in feet? Measure it. How many branches? That's a number. How many leaves? That's a number. Okay, so make sure you know qualitative and quantitative. Okay, accuracy and precision. We're going to go over this more. Remember, accuracy, are you accurate? Are you close to the desired number? So if the desired number is 100 grams, if you're around 100 grams, 100 grams, 99.9 grams, 99.99, 100.01, that's accurate. Okay, if you're at 70 grams, not accurate. If you're at 105, not accurate. Precision is just reproducible at whatever number it is. So for example, if you weigh 3 things and it's 50.0, 50.01, 49.99, that is precise because all of them are very close to each other. You're reproducing it, okay? Things can be accurate and precise. Things can be accurate and not precise. Things can be precise and not accurate. We'll get to that. Okay, and then last but not least, scientific notation. We will do examples of scientific notation. And all scientific notation is taking a huge number like 7,256,000 and turning it into something smaller that we can more easily use in calculations. So it would be something like 7.025, whatever number I just said, times 10 to the positive 9. Or we'll take a really small number like 0.00012 and call it 1.2 times 10 to the negative 5th, whatever it is, okay? Okay, so first thing we're going to do is we are going to do this one that says unit test 1. We actually already went over some of it, and also I'm going to go over it a little bit quicker just because, you know, I'm trying to pack everything into this one video, but this class did go over it. I think we went over almost this whole worksheet, but I'm going to go over it again for those who need it. Okay, so for this worksheet, it says, for the following descriptions, please write PP for physical property and CP for chemical property. So ready? Yeah, we already did it. I'm gonna go over it. Okay. First one, alcohols are flammable. So is this a physical property or is this a chemical? It's chemical because they add a flame to it. And remember, for physical properties, you're not messing with the substance. For chemical, you're changing the substance, okay? So adding a flame, changing it. A density of 3 grams per mil. You're just looking at the density, you're just looking at it, that's a physical property. Boils at 100 degrees Celsius. I know boils, you're like, oh, you're heating it, you're gonna melt it. But remember, heating, boiling, melting, physical property. Decomposes in CO2. Decomposes, it means it falls apart. It can't go back together. That is a chemical. Next one, attracted to the south pole of a magnet. If you just check to see if something's magnetic, you're just looking at a physical property. And then has a volume of 22.4 liters, you're just checking its volume. And it's still the same substance, okay? So that's physical. Next one. For the following description, please write CC for chemical change or PC for physical change. So remember, physical change, it's still the same substance. Chemical change, it's something new. Ready? Melting ice, still the same H2O, H2O, physical change. Burning popcorn, can't go back to original popcorn, chemical change. Digesting food because the enzymes are breaking it down, chemical change, can't go back. Molding clay, it's still clay, it's just in a different position, whatever it is, physical. Rust forming on a car, rust is a new substance, can't go back to metal, chemical. Dissolving salt, it's just like we did with the sugar, the rock candy. Even though it looks like it's gone, it's still in there. You can dissolve the water, or you can evaporate the water out and the salt will remain, or the salt will come back into solution a couple days later. Okay, so that is physical. Okay, second question. Okay, these are accuracy and precision. Okay, so suppose you made 3 different volume measurements of an unknown liquid that you knew to have a volume of 5.00 mils. Okay, so what they're saying is 5.00 is the measurement to be at, the accurate measurement. Okay, so I want my measurement to be at 5.00 mils. Okay, so for A, it says, give 3 examples of what measurements might be if they were accurate. Okay, so ready? Perfect. 4.99 mils. We could say 5.00 mils. We could say 5.01 mils. They are all very close to the true value. These are accurate. Now B, it says, give 3 examples if they were precise, which means they just have to be reproducible. Now, these are also, I'm just going to tell you this right now, these are also precise because they're reproducible. But I could give you some ones that are like this. 3.25 mils, 3.26 mils, 3.24 mils. These are all pretty precise because they're close to each other. Now, number C says, could 3 measurements be precise but not accurate? Explain. So ready? C, I'm going to tell you, look at B. These are 3 measurements that are precise to each other, but they are not accurate to the true value, which is 5.00. Oh. So yes, you can have 3 measurements that are precise but not accurate.
You can't have none that's accurate but precise.
Yes, but guys, the only way to have 3 accurate measurements is if they're also precise. Good. Okay. And then last but not least is scientific notation. So ready? Okay, so for A, you have 705,000, 400. So how do we write this in scientific notation? I'm going to actually also put B on there because A and B are both large numbers and follow the same positive rule, okay? 580. Okay.
7.054 the 5th.
Yes. So guys, do y'all see how these are large numbers? They're above 0. That means that whenever we do scientific notation, their exponent is going to be positive. Okay, so first thing you do is you make this large number a number between 1 and 10. But guys, you have to include all the non-zero digits, so it does have to go up to here. So like I heard, 7.054, it's between 1 and 10, times 10 to the, okay. What you do is now you say, okay, I put my decimal where it is and say, okay, how many decimal places do I have to move now to get it to behind the 7? 1, 2, 3, 4, 5. So this becomes 7.054 times 10 to the positive 5th. If you do this in your calculator, y'all will have a calculator with you. It'll come out that number. Okay, this one, what is the number between 1 and 10? 5.8, and you could continue to 0, 0, 0, but 5.8 times 10 to the, okay, I'm moving it over till I get to 5.8. 2 times, positive 2. Okay, guys, so this next group, these ones are going to be very small numbers. So their exponents are going to be negative.
Yep.
You have a question about that?
Oh, I was saying, I thought you was about to erase it.
Nope. So for C, we have the itty bitty number 0.00560020, and then for D, we have 0.2031. Okay, so first off, I want to make my number between 1 and 10, but I do have to include all of these non-zeros. So, good job, 5.602, okay? Times 10 to the. So ready? I put my
Negative
decimal. I got to get it to 5.6, so it goes over how many times?
4. Wait, 3.
3, good, so it's a -3, perfect. This one right here needs to include all of my non-zeros. 2.031 times 10 to the, how many times do I have to move the zero over, the decimal over? Just once, -1. Okay, we'll have more practice on this too. Okay, so this one was called Unit 1 Test. Okay, next one is going to be the accuracy, precision, and other stuff, worksheet number 4. Nope, you're keeping them. These are the exact same types of questions and just extra practice. So let's do extra practice, y'all. This is a lot of extra practice on scientific notation, so this is perfect. Okay, anybody still copying? Okay. Also, if you need any more examples of physical chemical changes or saturation, you can look at those notes prior, but this is plenty. Okay. So this is a worksheet we did not do in class, so we're going to do it together. Ready? Number 1, explain the difference between accuracy and precision. So, what is accuracy?
Something that could be close to and
Close to the true value. So ready? Accuracy equals close to true value. So you want an accurate number to be like exactly, if not just 0.01 off of the exact true value you are trying to get. But what is precise when it's
can be repeated.
repeated, consistent, good. And I remember the video, if y'all watch the video, it says accuracy, ACCU, oh my gosh, y'all, I can't spell, RACY. The second letter C stands for correctness. And precision, PRECISION, the second number stands for reproducibility. Okay, and so, reproducibility, yep.
Yeah, I'm looking pretty sure here.
It says, give examples of both accurate, precise, neither accurate nor precise, precise nor accurate. Okay, so ready, A. This one needs to be accurate, but, and precise. So guys, I'm gonna give you a number what to shoot for. I want you to shoot for 30 grams. So we'll just say our true value is 30 grams. So guys, if we give us, because accuracy means close to the true value and precise means that they're reproducible, if you give 3 things that are accurate, they're gonna be precise as well. So ready, if I wanna get to 30 grams,
30, 30, 30.
I could do 30, 30, 30. I want to just provide a little bit of variety.
Or, yeah, 30, 29, 30, 28.
I would say stay within 1 gram to stay pretty accurate, or 0.1 gram.
30.1.
Oh, I like that one, 30.1. Good. Now B says neither accurate nor precise. So not accurate, not precise. So guys, not only is it not going to be at 30 grams, but it's not going to be reproducible. So guys, shoot. 2.5 grams.
Yeah.
I think so. We said 30.5 grams and 17.5 grams. Because looking at these numbers, y'all, they are, well, that one, let's do, how about this? Let's do 38.
Is that 17.5?
Yes. So they are not accurate. And even if you had one that was accurate, they're still not accurate as a group. And they are not precise because they are not close to each other. Okay? So on your test tomorrow, I'll give you multiple choice answer choices, and you'll pick which one of these is not accurate and not precise. So
I gotta make it easier.
I think it's going to be easy. Last one, precise but not accurate.
30.G, 30.G, 30.G. But you only use it twice.
Hold on. Precise but not accurate. So guys, we need to have them precise, which means similar but not close to the true values. So now, how do we make them precise but not accurate?
29.2. Can I do that?
That's still too close. Let's do 22.2 grams, 22.3 grams, 22.4 grams. So guys,
Oh.
they are not accurate. So this one was precise but not accurate. They are not accurate to the 30 grams, but they are precise within each other. So you'll have multiple choice questions that say that, you know, which of these is precise but not accurate? Okay. Last but not least, just more scientific notation practice. So in class, you're going to have plenty of time to do these. What I'm going to do is I'm going to do 4 more up on the board and then just let, this is what I want y'all to do. Skip to 4. We have not done this one yet. So I'm going to give you the scientific notation. You write it out the long way. We have not practiced this one yet on the video. So ready? Question number 4 on this worksheet. Okay, so A, 2 times 10 to the third. What does that mean? Oh,
2,000.
good. So ready? First thing I would do, especially if you're new to this, is I would write the 2. And the 2 is the same as 2.0, so the decimal is technically there. It's telling me to move the decimal 3 times, and since it's a positive, it's getting bigger. So ready? 1, 2, 3. You're absolutely right. The answer is 2,000. Okay, let's do B. Yes, 3.5 times 10 to the negative 5th. Ready? Write out your 3.5. Uh-oh, I probably don't want to write it right there.
Yeah.
It's negative, so it's going to get very small, as in a very small decimal. So I'm going to write my 3.5 out over here. I need to move this decimal negative 5 times, so smaller. 1, 2, 3, 4, 5. So this is going to be, and I'm going to put just a 0 in front of it, that don't count. 1, 2, 3, 4. Yeah, so then if I would take my eraser, yeah, oh, good. Okay, C, 9 times 10 to the 14th. Oh my, this is a pain in the butt. Yeah, so all you do is say 9. Yeah, and then add 14 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If you need to go back and add the commas, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3. Yeah. Okay, D.
5.87 times 10 to the negative 2 out.
To the negative 2. Okay, so because it's negative 2, I know I'm going to need some room in front of it. 5.87. -2. I'm going to move the decimal to make it even smaller. So now it's 0.5, 0.05. Okay? Okay. Now, last thing we're gonna do before I let you finish this worksheet is that question number 5. It says, find the product for each of the following, and write your answer in proper scientific notation. So when everybody gets their calculator tomorrow, remember the video we watched, and there's 2 ways to put it in the calculator. You could either just so ready, we'll go over those. Okay, so all we're doing for number 5 is we're doing those multiplication problems. I'll give everybody a calculator. We're multiplying it out, and then we're putting it in scientific notation, because the calculator, no matter what, will just give you the long number. Okay, so does that one not work?
Yeah.
Okay. And then do y'all need another one over there?
Yeah.
Okay.
Thank you, senor.
Oh, we're on 31 minutes on the video. Okay, so guys, when you put this in the calculator for A, they're giving you easy numbers. They're giving you 37,000 times 7,000. Did you have to put that in the calculator special? No. So tell me, what is 37,000 times 7,000?
25,009. I don't know. About six zeros.
So somebody tell me the exact. Ready? 25.
100,000, 259.
How many zeros?
6.
Perfect. And that makes sense because 1, 2, 3, 4, 5, 6. Okay. So this is the number you get. Now we have to put this in scientific notation. So ready? 2.5 times 10 to the
8.
1, 2, 3, 4, 5, 6 power. No, 7.
7.
4, 5, 6, 7.
Oh no.
8.
No.
I get, yeah. 1, 2, 3, 4, 5, 6. Are you sure there was only 6 zeros behind it?
1, 2, 3, 4, 5, 6.
6.
You forgot the 9. It's supposed to
Yeah,
be
you forgot
25.
the
It's
9.
supposed to be 2.59.
Oh, so there's a 9 in here. Okay, perfect. Yeah, that makes sense. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Good. Okay. Now y'all, B is easy too. Ready? Put those really small numbers in the calculator. 0.0005 times 0.003 equals.
This one gives you 1.5 e to the negative 6.
So it gave you the
gotta,
E.
You gotta reverse that into the other number. Kind of the opposite.
Did anybody give them the small number in the long way?
Hold on.
0, it's 5 zeros.
0.0876.
It gave me 1.5
14956.
1.5 times 10 to the, what E did they tell you?
E negative 6.
Negative 6. I'll have to check with those calculators.
Right. Is that a 5?
Yes.
1.5.
Do you have glasses? Do you have
They
glasses?
broke. I gotta get them fixed. I just got them today too.
My kids, both of them, just got glasses.
Glasses been broken.
I mean, Nurse Lynn kept them at her house.
And you're good at sports even without glasses?
Day
Yeah.
1 of school.
Yes,
What
like
was
they're
your excuse in
broken.
pro phase?
Just to go. They're broke.
Tape, just a little athletic tape. We got plenty of it.
I got tape.
Okay, last thing I just need to tell y'all, real quick up here, is putting it into the calculator. So if we would skip to, for example, E. I like that one too. Okay, it says 7 times 10 to the 6th times 8 times 10 to the 5th. Okay, now y'all can listen, or I know a lot of y'all know this. There's two ways to put this in the calculator. You do have to keep the parentheses to keep them separate. You do 7 times 10, and then there's a caret. The caret is above the
Right there above the bar.
divided sign. So it's above the divided sign, and then you put a 6, okay? Multiplied by 8 times 10 caret 5, okay?
Right.
The second way to do it is using an E. 7, then you push the yellow second button, and above the 7, there's a comma. So when you do the yellow second button, it says second, and then you do the comma,
How?
it gives you an E, and then you just write the exponent, 6 times 8 E 5. Okay, what y'all get for that?
5.6 equals.
Oh, I messed it up.
Are you right?
What
I
was
don't
it?
know, is there maybe with the pencil or pen?
What's this?
How do you
Or
write
marker in
Ian?
some cases?
How do you write Ian?
So,
Oh,
yeah, it's a small E,
Y'all
but
got it, they can definitely.
Alpha
You
plus.
hit alpha, oh, and then you hit the